Josselin from Slither.
Thank you. Is it working? Yes, perfect. Okay, hi everyone. So welcome to this workshop on Slither. So first thing first, who am I? My name is Josselin Feist. I'm the engineering director of the blockchain team at 12 Bits. If you don't know us, we are a security company where we specialize in high-end security technology. We work on blockchain, cryptography, application security, machine learning, and so on. One thing which I think differs us from like other competitors is that we focus a lot of our effort into research and tooling development. As a result, we have built a lot of open source tools. You might know Slither, which we're going to see a bit more deeper today, Echidna, Caracal, Medusa, and so on. But today I'm giving this workshop because we have a prize for the hackathon, which is a 2K prize based on the best kind of like a project, which is going to be built on top of Slither. The goal of this workshop is going to give you a quick insight into how Slither works, how can you extend it, what can you kind of benefit from it, and to help you to go through like this bounty. We are giving a couple of examples of things that we believe you can build in a couple of days with Slither. For example, we have a new VS Code plugin, which is going to allow people to create custom analysis and custom visualization for smart contracts. You can build on-chain monitoring. For example, you can use Slither in a way that you can kind of query the different variable state over the time with different block number. You might be able even to build some kind of machine learning extension where you build a custom kind of Q&A bot with Slither and Longchain. You don't need to work on this project, but it's just some example of things that you can work on. In terms of criteria, what we are really looking for is novelty. We want to see kind of interesting idea from the project, and we're reliant on Slither. The more you use Slither in your project, the better it is. We also have on critic/ETHDam like all the rules. We have a couple of API, a couple of video, and a lot of things to help you getting started. Okay, but here we are going to quickly see what is Slither, a couple of internals and API that you can use, and yeah, how to get started. You might know Slither as a command line tool. You might have been using Slither to find vulnerability in your code base. 90-ish% of the people that are using Slither use it that way. They just run Slither, code base, and they run a bunch of detector. The thing is that Slither is actually much more than that. It's a full customizable static analysis platform where you can use all the analysis that we have built for the detector to build new things, as we're going to see today. Slither is open source. It has been open source for like, I don't know, 5-6 years now. It's in Python, and yeah, it's on GitHub. As I mentioned, most of the people use Slither just from the command line, but you can use its Python API to build any type of tools. Here is an example of tools that we have built ourselves on top of Slither. For example, Slither check observability. It's a specific tool to check for common flaws we have seen in delegate call-based proxy. Slither read storage. So this one is a tool that is going to connect Slither with a RPC node and give you the information of the what are like the variable value of the given smart contract which is deployed. Typically, as you might know, there is like all the storage layout in a smart contract. When you have like a variable at a specific slot, Slither will automatically find out where it is in storage. Another one is Slither check ERC. This is just going to try to check if your contract is compliant with a given ERC. ERC20, ERC721, and so on. It's just going to apply a bunch of criteria and check on top of it. Before I go a bit more further into the API, is there any question? I cannot see well. Okay. So here I'm going to give you a couple of kind of intuition, hints, and example into how to use the API and how you can kind of manipulate everything that Slither gives you. It's in Python, so you need a bit of Python understanding. To give you a really quick example of things that you can do on top of Slither, so, and this is not working, oh, sorry. Yeah, so here, basically, you create a Slither object, you open a file, you can retrieve a specific contract, retrieve a specific variable, and you can ask Slither what are all the functions in this contract that write to a given variable, and then you can print it. So you can see with 5 lines of code, you can already manipulate a contract, extract some information, and kind of process it. So how does it work under the hood? What Slither does basically is that it's going to take what is called the so-called AST, so abstract syntax tree from the compiler. It's just a representation of the code base that the compiler is giving us. Looks like this. It's a tree where every node is either an operation or a variable. Slither takes this and do a bunch of analysis and a bunch of kind of recovery of information. And on top of that, it's going to provide you 5 layers: compilation unit, contract, function, control flow graph, and expression intermediate representation. And we are going to see what is every layer now. But first, something I wanted to highlight. You might have used Slither most of the time on a code base. You have like a Solidity file, you have a project using Foundry, Hardart, and you just want Slither on top of it. What you can also do is you can provide an address, and if the code is on ETHDam, you will be able to directly analyzing it. For example, in this example, on line 3 or 4, we create a Slither object, we pass the address of USDT, and Slither is going to retrieve directly the contract from ETHScan and compile it, parse it, and do all the analysis. If you do that in a kind of in a bot, or if you do that in a way that you are going to do a lot of query, I would recommend to use the flag ETHScan API key to provide an ETHScan API key. This is just if you are going to hit some rate limit on ETHScan. We support almost all the testnet. We support Binance Chain, we support Arbitrum, Optimism, like any kind of like ETHScan-like platform, you can directly provide the address through Slither. So as I mentioned, the first layer that Slither is going to provide you is a compilation unit. What it is, it's basically a group of files that was used that was used to do one call to the compiler. Why there is this notion? When you have some compilation framework, you might have multiple calls to the compiler. For example, in Foundry, if you have some of the files that are be compiled by Solidity 7, some of the files that are going to be compiled by Solidity 8, the compilation under the hood is going to call multiple times Solc, and every time you are going to get one compilation unit from Slither. How to access them? So you create the Slither object, Slither.compilation unit, which is straightforward. Why it matters? For what you're going to do during the 3 days, it probably don't matter for you because most of the case you are just going to have one compilation unit. That say, when you are going to look at the API from Slither, some of the API might not seem kind of straightforward or might not seem intuitive because we have this notion. So most of the time for you in this hackathon or when you want to quickly hack on top of it, you can just use the first element of the compilation unit array, so compilation unit bracket 0, and you will be okay. If you want to build something more robust that is going to support any type of platform and any type of a project, you might need to support multiple compilation units. Again, TLDR for you for the 3 days, just take the first element. What can you have as information from this? So you have the compilation unit, you can get all the contracts, pretty straightforward, all the contracts from the project. Contract derive, this is a kind of like a simplification that gives you all the contracts that are the most derived in the inheritance tree. Most derived, basically, if you have contract A, you inherit contract B, you inherit contract C, and so on. The most derived will be A, like the one which is not inherited again. Typically, when you work in a code base with multiple contracts, you might want to only analyze like what's the end result. Like you don't care about like the intermediate one. If that's the case, you can use contract derive. Get contract from name, pretty straightforward. You provide a name, it retrieve a contract object. You can also access all the top level objects, structure, enum, event, and so on with the relevant provider. To give you a quick example, so here we create a Slither object, we pass the USDT address, we take the first compilation unit, and we just print what are like all the contract, what are all the contract derived. So this is on USDT. And if you print that, you can see here's the difference. So here you can see an example of contract and contract derive, while the second line is contract derive. The first one is all the contract. Typically, ERC20 in USDT doesn't appear in the derive because it is inherited by the Tether token, which is pretty straightforward. You have Tether token, which inherit from ERC20. Any questions so far? We have only 30 minutes, so I'm going to go as quick as I can, but I also want to make sure you understand like the different steps. Once you have the contract object, you can query a couple of internal things. For example, the name, which is straightforward. Inheritance, so this is going to give you the list of the inheritance or the list of contracts which are inherited from this contract. You can go the other way around. You can call derive contract. It's going to give you from this contract all the contracts that derive from it. So you can basically go both ways in the inheritance tree. You can get enum, event, structure, again, like all the different things that you can get access to in a contract. On the variables themselves, you can get all the state variable of the contract. You can also follow the order of declaration if that matters for you. Get function from signature. It's going to retrieve a specific function based on the signature. Pretty straightforward. Simple example again. On all the example, I'm going to reuse always USDT as an example. So the first line are always the same. What matters here is the one in the red box. So what we do, we fetch a USDT contract. We take the USDT token, so Tether token, and we print for this contract all the state variable. Again, 5 lines of code, and you can see you can already play a bit with like the API. And this is all the state variable in the USDT contract. Okay, then you can go one step further. So you can look at the function. From the function, you have the solidity signature, pretty straightforward. Entry point is a node. So a node, we'll have a couple of examples later, but basically you can have a graph representation of the function where you can have like all the different operations of this function and you can kind of walk through them. The different elements, expression, variable, modifier. A couple of helpers that might kind of speed your usage. You can get all the variable, local or state that are read or written. So for a specific function, Slither in one command can give you an information about everything which is read or written. All this function can be prefixed by all. If you do that, you do a recursive lookup over all the internal call. So for example, if you have a function and you just want to know what are the state variable read by this function, but you don't care about the internal call of this function, it's just state variable read. If you want to do it and you want to consider what is inside the internal call, just add the prefix all before. To give you an example, here we are looking at the same USDT token. We are looking at the total supply function, and we are asking Slither to print all the state variables that are read by the total supply function. 3 state variables. Now, if we want to kind of understand a bit better the difference between having or not the all kind of prefix, so we do the same, but for the transfer function, and we print all the state variables that are read by the transfer function and all the state variables that are read by the transfer function and its inner call. You can see like there is a difference, and the reason for that is that if you look at the transfer function of USDT, there is 2 internal calls, one not pause, which is a modifier, and a call to super. So basically here, depending on what you want, if you want just to look at the function itself, or if you want to look at the function and its inner call, it's going to be important to use the proper API. Okay, any question? So this is a workshop. I was hoping to have a bit of table for you to play around with it, but we have a couple of exercises to try Slither on. So if you go on securecontract.com, program analysis Slither, you will have the first exercise. It looks like this, where basically we are going to try to use the Slither API to manipulate the code. Let me zoom in. Can you see it? Yeah. So here our goal is going to create a Python script that is going to go over the contract and try to implement an overwrite function protection. So basically, the algorithm is here. So you get over the contract, you iterate over all the different ones. Once you find the correct contract, you just check if the min function has been overwritten or not. Let's see the time. How many of you have a laptop? Yeah, a couple. So I'm going to give 5 minutes to try this, and in 5 minutes I will give the solution. Yeah. So securecontract.com. I should have made a QR code. That's on me. And if you go in Secure Contract, there is also like an API page. And I don't have internet. But if you go on the API page, you will see a lot of examples and you will see like a lot of hints on how to use it. Yeah.
Sorry, excuse me. Do you use this SDK for the slicer tool, or is it kind of another tool that you propose?
So Slither is built on top of the API. Basically, when you use it like from the command line, under the hood, we are using all these different functions and all these different things. For example, all our bug detectors, so we have like something like 19-ish bug detector, are built on top of this API.
Okay, so everything is right on Python, right?
Yes.
Okay, good. Thank you.
Hi. Could you explain who is going to be the user of the SDK in the way that you explain it now? Is that the developer who is developing the project and you just want to write an alternative test, or it's the auditor?
That's a really good question. So I think most of the time it's going to be security researcher where they're going to build either custom detector, custom script, or things like that. Typically, for example, during a security review, we might have a need to build like a custom analysis just for like the purpose of our client. So most of the time we do it. Let's say a developer might also try and build its own like kind of conformance tool or like analysis. But most of the target is more on the security researcher side or developers that are a bit more advanced with this type of techniques.
And I have a feeling that it's going to be useful for, I don't know, big projects and when there's like ton of functions and something like that. If you have a small project that's like overhead to write actual like thing you want to test, to check, right?
I mean, it depends. It depends because let's say you write a library, right? Like a small library, like 300 line of code, and you want to make sure someone is going to use the library the way you anticipate it to be used. You might just build custom script on top of it and provide the script as a way for people to test. So it depends. But if you write like an ERC20 token and that's all you write, yeah, probably that's overkill. So it depends. For a company, like what we have seen also is that, for example, people might want to kind of enforce specific style or enforce specific kind of like a pattern. For example, and the second exercise is going to be about that. Like, let's say you want to have a whitelist-based approach for your function. All the function need to be named, I don't know, like something. Otherwise, they need to have a modifier with an access control. And this type of things you can programmatically enforce them with Slither. And you can say, okay, like all the public function have either a modifier or are within like this list of name. Does it make sense?
Yeah, it makes sense. I have a feeling that I can use it like a prettifier.
You can also do it like that.
Like
Yeah.
to incorporate it with like CI/CD.
Yeah.
And like run it all the time when I have a pull request, something like that.
Yeah, we actually have a Slither action, so it's a GitHub action that you can plug into your CI, which is going to run all the detector and everything related. Okay. Has anyone managed to find a solution for this one? Okay, but basically it would look like that. So once you have the Slither object, you can iterate over all the contract. And what you are trying to see is that you are trying to see if the function was overridden by another contract. So it's just algorithmic. It's just you iterate over all the contract, you get the function, you check if the function declarer is the one you're expecting. If it's not, it means that someone has override this function. Second exercise that you can find on secure contract, I'm going to go quickly for the sake of time, but it's kind of like the same idea. Here, what we are trying to do is that, it's kind of what I was hinting. Let's say you have like a code base when you want to impose a specific style for your access control, and you want to say, okay, all the function have the only owner modifier in this contract except A and B. Then you can use Slither to create this type of kind of script. So basically what it would look like, let's say in your contract, in your code base, only balance off doesn't need to have only modifier, only owner, which sounds pretty straightforward. Then you can explore the code base, you can explore all the function and just check if the function visibility is public or external, otherwise it's an internal function, and check if it's within the whitelist that you have created. Like the code mostly here, it's like generic Python script. You just iterate over the function, check if your function is in the whitelist. Does that make sense? As you can see, because it's in Python, you can pretty much develop any type of logic. You can develop any type of kind of application, and Slither gives you access to all this information for free. Yeah, same for the third one. This is a bit more kind of a specific use case that you might have, in particular when you do a code review. You want to find which function use a specific variable in a condition. Condition can be require, can be like, if then else. When you do like an audit, when you do a code review, sometimes it's really important to be able to say, okay, how this function is, how this variable is used, how in the code base it's going to influence and impact. And condition, it might be something you want to look for. To do that, again, it's kind of straightforward with the API. You can get the variable from the contract object. Then you can check if this variable, in which function this variable is used in a conditional node or in an assertion require. I'm not sure you can see it. Yeah, it's big enough. But yeah, basically in a couple of lines of script, you are able to implement this type of tool, this type of specific need. So yeah, from like a security researcher perspective, this kind of speed up your process significantly. Any question? Okay. Something that we released yesterday in time for the hackathon. So we released a new VS Code plugin that uses Slither as a backend. The way it works is that we have an LSP server, if you are familiar with that, basically just like a standard format for Code Explorer. What it does is that it's going to allow the VS Code plugin to communicate with Slither and to receive all this kind of information and provided API. So the VS Code plugin can do things like go to implementation, go to definition, find all the reference, show like the call and type hierarchy. For example, here, you click on a modifier and it's going to show you like the call hierarchy of the modifier. pretty standard for most of the common language to have this type of things. For Solidity, it's either lacking or it's kind of like in a work in progress. So we have developed a plugin to do that. It's really easy to hack on top of it. You can find the link in the ETHDam repo too, where basically you can just add any type of handler on the LSP side, so on the server side, the backend side, and just develop an interface for it. This is an example of things that you can probably, if you're interested, hack on top of doing this hackathon, and it's covered within the bounty. So where to start? Secure contract, as I already showed, we have a bunch of exercise. We have more detail about the API, more detail about how to use it, and about static analysis. If you clone the GitHub from Slither, we have Slither/tool/demo repo, directory, sorry, where you find a bunch of kind of default parsing argument and just everything to get started much quicker if you start instead of starting from scratch. You can also take a look at the Slither detector code base just to get a sense of the API, how we use it in a more efficient way, what we can build on top of it, and so on. And yeah, so as I mentioned, Slither is an open source framework. You can build any type of analysis on top of it. We have the hackathon with a 2K price. You can scan the QR code to go into critique ETHDam. We have a Discord channel, 12 bits. You can also ping me directly on Discord. We have a GitHub, a Slack if you have like further questions after the hackathon. Any question?
Any final questions for Josselin? Yeah.
Yeah, thank you. I just have a question more about Slither. So from my understanding, it's kind of a SAST tool, so static analysis component. And do you do also SCA analysis from, I don't know, from libraries, from, I don't know, OpenZeppelin that have some vulnerabilities on it? Is your tool can, I don't know, manage that and have warning also?
Yeah, so here I show Slither from like an API standpoint, but it can also be directly out of the box used as a command line tool. And if you use it as a command line tool, you are going to get access to all the detector that we have already implemented. And if you do that, yes, you can directly find vulnerabilities. And we have something like 90-ish detectors that have been built based on what we have seen during our different code review and audit.
Okay, and about that, I'm also interested about kind of the database that going to say, okay, this package is vulnerable for this one. Do you have kind of open database for that? I mean, how is it managed?
Not at the moment, but it's something we are considering.
Okay, thank you.
Thank you very much. That was excellent.